Okay, so good morning. We continue the lesson. There are a lot of things to cover today, so I have written the notes a little bit more extensively, but many of them I have to actually escape, unfortunately, but I will try to keep the more important parts that are a little bit problematic for you so that you don't have any problems. Okay, so without further ado, let us start here. So as you see, this time we learned about the limits whose answer is infinity, minus or plus infinity, but we want this time to send x itself to infinity, either plus infinity or minus infinity, okay? So for example, if I want to give you the idea, so consider this function here, yes, this is your function. And then I have calculated the value of the function for some values for x. For example, when you choose x to be 0, f of x is 0. If you choose 1, it's a simple calculation. I did it with calculator. And then you see that when I start increasing the values of x to very large numbers, of course here is 1000, there is some pattern reveals itself here, and then you see the values of the function are getting closer and closer to a particular value, yes, which in this case is 2, yes. So in this case we say that the limit of the function as x itself goes to infinity is 2. So again, if I want to give you an informal definition of this, we say that let f be a function that is defined on this interval. It should be defined from some point onward, of course, otherwise I cannot send x to infinity. We say that L is the limit of f as x approaches infinity, and we write this. If we can ensure that the values of f get as close to L as we want to by taking x sufficiently large. Yes, that's the meaning of this. Is that clear? So it means that when I increase x, so the values of the functions are approaching a particular number. Okay, we can talk a little bit about sending x to minus infinity. You can guess what is going to happen. Yes, here I have the same function, but I am making x smaller and smaller and smaller. And then you see that again, the values of the function are getting closer and closer to the particular value 2 here. So to show this behavior, I say that the limit of the function f of x as x approaches to minus infinity is again 2. Here it's a coincidence. There is no guarantee that the left and the right limit, sending x to plus infinity always give the same number as x goes to minus infinity. So some idea, is that clear? Okay, so yeah, I have written here, so I want to just start with a theorem. Okay, so the theorem is very simple. You already know what that is. So if I have a number and I divide it by a large number, what happens? It becomes small. Yes. So now let us say that I have one fixed number. I divide it by a very, very big number. What is your intuition? What is more or less left out of this division?
It's going to go to 0.
It's going to be 0. Okay, so these are the famous ones that we have. So the limit of 1 over x to power a is a positive real number here. X goes to infinity, this becomes 0. Yes, because a is positive and I am making x extremely large, and then I am dividing 1 by an extremely large number, so the limit is 0. And even for the minus infinity, it would be the same. But if I want to say that x goes to minus infinity, a should also be positive here. So I have written here that a should be positive. Yes, so it doesn't matter. Okay, so let us start solving these examples. I will not be able to solve all of them, but I will pick some of them. Okay, so let us take some of the first few ones. So I want to calculate the limit what is that? 3x minus 2 divided by 5 minus 6x, and x approaches to infinity. Okay, so one thing I want you to understand, usually you need to understand what happens. You remember when x went to numbers, I just replaced the x with number to see what kind of indeterminacy, what kind of problem I have. more or less we do the same thing. What will happen if I put x to be a very, very large number? What do you guess? What happens for the numerator? If x is extremely positive large number, it becomes extremely positive large number. But what about the denominator? Extremely large negative number because of that. So it will be infinity over minus infinity. I want you to know that is also another form of indeterminacy. Okay? So depending on the behavior of the functions, if you have infinity over infinity, the answers might be different. Okay? So in order to solve this problem, I want you to learn these techniques. So if x goes to infinity and you want to solve it, the best way is to use the theorem I just mentioned. So what do? You divide the numerator and the denominator by x here. So this becomes 3. This becomes minus 2 over x. And then divided by, this becomes 5 over x. And then this becomes 5 over x minus 6. And then I send x to infinity. Yes? Okay, so this is valid. I can divide both numerator and denominator by the same number. And I'm sure that this number is not 0 because x is very large. And then what can I do? Of course, the limit of this part becomes what? When x goes to infinity. The limit of this part becomes 0 because that's a fixed number divided by a huge number. So according to this theorem, nothing is left. In limit it is 0. And what about this one? This one is also 0. And then what is left for me is 3 over minus 6, which I can simplify it as minus 1 over 2. So when x goes to infinity, dividing by some appropriate power of x is something that you need to know. Okay? So we will explain more. So let us go to the next problem. Any questions here? Please interrupt me if you have questions. So the next one is the limit of 2x squared minus 2x plus 5 and then divided by 3x squared. 3x cubed.
Yeah.
And then
Minus x plus 1.
minus x plus 1. X goes to infinity. Okay, so if I want to give you an intuition, what is your intuition about how it works? I mean, if I put infinity here, it becomes infinity, this is also infinity, but infinity minus infinity, we learned that that's also an indeterminate form itself, and the same thing happens itself here. But if you see here, from these powers, x squared is much larger than this one. If x is extremely large, then 2x squared will dominate 2x. Let us say that x is 1000. This is of order of 1000, but this will be an order of million. So if x is very large, you can ignore this. But I want to have this intuition. So in principle, you can ignore everything except 2x squared in the numerator, and you can ignore everything except 3x cubed in the denominator. But this is the intuition. This is not the way that you write in the exam and get points. You have to be a little bit more careful. So what we do here, we divide everything by the largest power. So remember, if the degrees are the same, you divide by that degree, x to that power. But if the degree of the denominator is bigger than the degree of the numerator, here it is 3 and this 2, you divide by the highest degree, okay, everything. So this becomes the limit. So let us do it in our head. If I divide this by x cubed, can you do it in your head? What happens? 2x, let me write one of them. 2x squared divided by x cubed. What will happen? It becomes 2 over x. Yes? So the first one becomes 2 over x minus. The second one will be 2 over x squared, and the next one will be 5 over x cubed. And when I divide the denominator by x cubed, the first one becomes just 3, the next one becomes this, and the next one becomes this. And x goes to infinity. Is that right?
Mm-hmm.
So, but you have to remember, if the degrees are the same, divide by the same degree. It was 1, so I divided by x to power 1. Here, I have the scenario that the degree of the denominator is more, so divide by the degree of the bigger one. So, is the algebra clear?
Yes.
Okay, but then can you tell me what the answer is? Again, all of these are 0, yes? So this is 0, this is 0 in limit, this is 0, this is 0, and this is 0. So what is left for me?
0.
0 in the numerator and 3 in the denominator, yes? Okay, so this becomes 0 over 3, which of course, as you said, is. Okay, so let us, please interrupt me if you have questions. Okay, the next one is the other way around. Can you see that? So let us this time send x to minus infinity. Okay, so, and then I have 1 minus 4x cubed, and then divided by 2x squared minus x plus 1. So here the scenario is different. First of all, for diversity, I send this time x to minus infinity, and this time do you see the difference? The degree of the numerator is more than the degree of the denominator. So in this case, what you are supposed to do, can you see what to do?
You divide both numerator and denominator by x cubed.
X cubed works, but there will be some technical problems. And I also checked the book. The book tells, I think correctly, that it is still better to divide by x squared. Okay, so let us...
degree of the denominator.
Yes. So then let us do that. What you said technically is not wrong. Okay, so if I divide by x squared, this becomes 1 over x squared. Then this becomes what? Minus 4x. This becomes 2. And then this becomes 1 over x squared, and then 1 over x cubed. And then
We
x
divided by x squared though.
what?
We divided by x squared, so it should be minus 1 over x plus 1 over x
Yes,
squared.
yes, thank you. Thank you very much for that. Okay, and now what happens? As before, this is exactly 0 and 0 and 0. Okay? So these are not subtle things. So what is left, 1, 2 is left in the denominator, and what is left in the numerator is minus 4x, but x goes to minus infinity. So what happens to minus 4x if x is minus infinity? It becomes plus infinity, but there is 1, 2 left here. So it is like that, I am dividing plus infinity by 2. We had this yesterday. It seems that I am multiplying 1 over 2 by infinity. So it becomes what? Infinity, and that is the plus one. So whenever I write infinity, I always mean plus infinity. So this is the main idea of calculating the limits when x goes to infinity. Is that right?
Yes.
Okay, but there are some, of course, harder questions. For example, let me skip 4. The difference between 4 and 5 is just that. Okay, I have to show it here. So the difference between 4 and 5, as you see, is what? This is the same function here and there, but here it goes to infinity, here it goes to minus infinity. Okay, the infinity is simpler. Let me solve number 5. Okay, so number 5, I hope that you see the difference. I have one square root involved in the problem now. So number 5, I want to write limit x goes to minus infinity, and then I have 3x plus 4. And then I have a square root of 5x squared plus 2x minus 1. The idea is more or less the same. I want to divide by an appropriate power of x. Okay, but I think it is better to deviate a little bit from our strategy. Instead of dividing, whenever you have this square root, try to factor an appropriate power of x. So the highest power. Okay, so what I will write, you will see that the nature of this solution is very similar to what we have. The idea, the philosophy behind the solution is the same. But let us be patient a little bit to see why it works. I copy and paste the numerator, and I told you that factor x squared out. You will see why this is good, because then it becomes 5. This becomes 2 over x, and then it becomes minus 1 over x squared. Do you have problems in factoring? Is it okay?
No.
So why this is a little bit good? At least these are not problematic anymore, because they will be 0. But what happens for x squared under square root? Can you tell me? What? So I want I have a square root of x squared. What should I write?
Minus x outside the
I have to write, in principle, I have to write
absolute.
absolute value. Do you remember I told you that's a common mistake. So this becomes the limit of 3x plus 4, and then here this goes out, but the square root of x squared, be careful, it is absolute value of x always. So this becomes absolute value of x, the square root of 5 plus 2 over x minus 1 over x squared, x goes to minus infinity. And I told you that it is always better to get rid of absolute value sign. You couldn't do it unless you know about the sign of the expression inside. If it is certainly positive, just simply remove it. If it is certainly negative, remove it and put a minus sign. So is that okay now? So what should I write now instead of absolute value? Because x goes to minus infinity, this becomes minus x. Okay, you can a little bit adjust yourself in how much you want to write, but you have to be precise in your explanations. So you have to show that I know that absolute value goes out, and then I change absolute value to minus x. Because if you solve the positive one, so you might mistakenly put it out and write x, and it works fine. But that was a coincidence. Yes, I want you to know. So now can you tell me what is the next step from the experience you got here?
Sorry, can you repeat why, when you get out of the absolute value, it becomes negative?
Oh yes, because first of all, this absolute value, but x goes to minus infinity, it means x is a negative number, is a huge negative number. And I told you in the first lesson, if you know what is inside the absolute value is negative, you are allowed to remove the absolute value, but you have to put an extra minus sign. Do you remember the definition of absolute value was this?
Okay.
Yes? Understandable?
Yes.
Okay, so that's why we pick up a minus sign. And can you tell me what to do next? What should I do next? From the experience you have here. This is okay, but this is not okay, this is not okay. Somehow I want to get rid of it. Can you tell me what to do? Divide by x. Divide by x, very good. So if I divide this by x, this becomes 3, this becomes 4 over x. This x is gone because I am dividing, minus sign survives. And then I have 5 plus 2 over x minus 1 over x squared. And x goes to minus infinity. Is that clear? So that's also one type of problem you should have in mind. And then of course you know what to do now, yes? Because this one is 0, this one is 0, this one is 0. So what is left for me? A 3 is left on the top, and minus square root of 5 is left here. So if you didn't pay attention to the absolute value, the answer you might get is 3 over square root of 5, which is wrong for this case. It is true for the previous case when x goes to plus infinity. So I would prefer to write it as minus 3 over square root of 5. Yes, understandable?
Yes.
Okay. So I want to solve two more, number 6 and, for example, number 9. Okay, so number 6, I want to count on you how much you have experience now. So how can I solve this problem? 2x minus the square root of x squared plus 1, x minus 2, and then because usually the minus infinity is a little bit problematic, I usually want to solve the minus 1. Okay, so do you have any idea what to do?
Factor the x out of the square root.
Here, yes, you mean x squared, very good. So let us do it step by step. So I copy and paste the denominator. I copy and paste this part. From the experience you now know, I factor x squared out. So what is left? This becomes 1 over x squared. Is algebra clear for you?
Mm-hmm.
Okay. And then x goes to minus infinity. What is the next step? You have experience, so what's the next step? Copy and paste these parts. The square root of x squared gives me, in the exam, show that you know this, okay? Even though you can calculate it in your head, but in the exam you have to write these things. Okay, now you say that x goes to minus infinity. Am I allowed to remove absolute value? Yes, because I am certain this number is negative, but the price that I have to pay is to put an extra minus sign based on what we learned before, yes? So this becomes now plus x. Yes? Okay, and then experience from the first column, what should I do?
Divide by x.
Divide by x, very good. So, yes, that's it. So I divide this by x, I divide this by x, I divide this by x, I divide this by x. And you know what to do now, yes? This one is 0. This one is also 0. So what is left for me is 2 plus 1 divided by 1, which is... Yeah, is that clear?
Okay.
Okay. So let us go to the next one. Let us solve number 9. So the limit of square root of x squared plus 2 plus 2x minus square root of x squared minus 2x, and then x goes to minus infinity. So I think this is something similar to what you have in the workshop problems. Okay, so this is something I want you to know. Okay, first of all, let us understand the limit. So if x goes to minus infinity, can you tell me, based on your intuition and what you have learned so far, what I can say about the first term? If x is a very huge negative number, what do you think about this term? Is it a huge negative number, is it a huge positive number, or is it just a normal final number?
It's going to be a huge positive.
It's going to be a huge positive number. First of all, between x squared and 2x, I can simply in my head intuitively ignore 2x because this is more powerful. And then x goes to minus infinity, so x, this one to the so it becomes absolute value somehow, and absolute value is plus infinity. So this is plus infinity, approximately, I mean roughly speaking. Okay, forget about this and concentrate here. What do you think what happens if I put a very large negative number here?
And it can be the positive number.
This is also a positive infinity. But this is positive infinity, this is positive infinity, but there is a minus sign here. Okay, so what I'm saying is that if I had given you this, it is actually extremely simple. What is the answer?
Infinity.
Infinity. Because if it is plus, you have plus infinity, it becomes infinity, you really don't need to do anything at all. But if I give you this, this becomes a little bit harder because this is infinity minus infinity, depending which one is larger, how it acts. The answer is indeterminate, so we have to determine it, yes? So how should I do that? There is a trick here. Any ideas?
Factor the x for number first.
But do you think it will work?
Maybe.
No, yes, let us be imaginative. I factor an x, there will be an x here, there will be an x here, and then I can factor an x out, and there will be two square signs left again.
If we multiply it by the...
So let me just quickly do that.
Yeah.
Let us do it in your head. I hope that you can see there will be an x out with minus sign, and there will be something like this. There is minus sign because absolute value becomes minus, and then I will have this one. Okay, that is a good idea. Let us say that why this doesn't work. It is good to know why these methods does not work. It becomes something like this, trust me on that. So you factor x squared, it becomes absolute value, but absolute value is minus. So I put a minus sign out from both of them and I will get this one. Somehow it seems to be correct, but I want you to understand, if x goes to minus infinity, what happens here? It becomes 0. And then this becomes plus infinity. We haven't talked about that, but 0 times infinity is another indeterminate form. So this method is not technically wrong, but it is changing one indeterminate form, which is infinity minus infinity, to another indeterminate form, which is 0 times infinity. So it is not wrong, but it has changed the problem from one indeterminacy form to another. Okay? So that's why it's not working, unless you know what to do with this one. Okay? So that is why it's always good to understand, if you want to understand mathematics, it is always good to check these methods and know why these methods are not working. Okay, so this is not working apparently. And then, what else comes to mind? Yes?
Multiplying by that square root plus.
Yeah, the conjugate. Based on experience you gained before. So memory plays a vital role in mathematics. Of course, you have to understand but finally you have to have the method in mind. Okay? So we solved this similar problem here in a different context. But the idea can also be used here. So let us do that. So let me write it a little bit quickly. So what I will write, I copy and paste this part, and then I multiply it by 1. But I write 1 in a fancy way, which will work. I write 1 in this form. You might say, how this comes to my mind? How should I know about this? Okay, the answer is that, first of all, you might come with this idea, as one of your friends did, or you might see it once, but remember it for the next time. That is what you have to do, okay? So x squared plus 2x plus... And by the way, that's why mathematics is good, because it tells you how to be a good problem solver, okay? So it doesn't matter if you really want to do mathematics or not. The way the methods, the strategies you work here is very instructive. So, now hopefully you know the algebra. So, I multiply this by, first of all, do you agree I am allowed to put equality sign? So I am not cheating, yes? Because what is this number? This number is 1. When I multiply this by 1, so this is completely valid. But now why this is good? Because if I multiply this by that, it is the conjugate rule. So it becomes the first one squared minus the second one squared. Is this the correct way of writing?
No.
No. What should it? I should put pair of brackets around. Okay, and then there is a denominator 1 here, which is multiplied here. Okay, so now let's do algebra a little bit faster now. So what is the numerator now? Multiply minus in x squared gone, plus 2x, 4x. And now because of the experience you have, so let us not waste the time. What should I do? I factor x squared here. I factor x squared there. Yes? And let us go one step forward. So this becomes absolute value of x, square root of 1 plus 2 over x, and then plus absolute value of x, square root of 1 minus 2 over x, and x goes to minus infinity. Yes? But if x goes to minus infinity, I can replace absolute value with minus x. And if you don't mind, let me, to save time, factor a minus x out. So this becomes the limit of 4x. I factor a minus x out, square root of 1 plus 2 over x, plus square root of 1 minus 2 over x. Okay, x goes to minus infinity. Do you agree?
Yeah.
And then what is happening? Do you agree that this x and that x are gone? Okay, so this x and that x are gone. And I am sending x to minus infinity. So this goes to 0, this goes to 0. Yes? So what is happening now? So it is 4 in the numerator, I have a minus sign here, and I have 1 plus 1. So the answer is minus 2. Yes? Okay. Any questions? Okay, so, yeah, I have to speed up. Okay, so let us go to the next one. You can read this yourself. For example, here I told you that if you want to send the limit of a polynomial, so which one is the dominant term? Dominating term is the term with the highest degree. So you can ignore these. Oops, I don't know why it's not working. Okay, you just keep this 3x to the power of 3. So you can ignore the rest. And when x goes to infinity, 3x cubed becomes infinity. Yes? So please read this remark yourself. I'm sure that you understand how it works. Okay, so a little bit problematic thing is this. Now we want to switch the topic, that is trigonometric limits. So I have sine, cosine, tangent, other trigonometric functions, and I want to talk about the limits. First of all, I want you to know these things. So sine and cosine are very user-friendly. If you want to take the limit of sine or cosine when x goes to a, you just replace x with a. Okay. In principle, intuitively it is clear. Why? Because, for example, if I send x to 45 degrees, if I talk in degrees, sine of 45 degrees sine of x becomes close to sine 45 degrees. Okay, so that's not very weird, but of course I know that this is not a proof. But trust me on that, so remember them. Any questions here? So if you want to calculate a limit of sine and cosine when x goes to a particular number, then you just replace the argument with that number. What about limit of sine of x when x goes to infinity? So because we are learning x goes to infinity, what happens? So it is not that easy, but it is mathematically proven that the limit does not exist, okay, in any sense. So it is not infinity, it is not minus infinity, because you know sine and cosine are bounded functions. But it is also possible to show mathematically rigorous way that there is no particular number that sine x approach when x becomes extremely large. Okay? And that's also somehow clear because sine is oscillating, yes? So it is not very clear. When you say I am at infinity, it means that I am on the right end of the x-axis somehow, but you don't know exactly where, so it is oscillating. So that's an intuition about it. So let us, for example, solve these two problems. They are simple. So the limit of, what is the first one? Sine x plus 2 tangent x. X goes to what? Pi over 6. Okay. So one thing I know is that tangent is what? Sine over cosine. Yes. And then x goes to pi over 6. Pi over 6. Of course, you know you have to, you can write it in the exam like this, because you see, in principle, you have to calculate limit of sine x when x goes to pi over 6. You just replace x with pi over 6, and then you do the same thing here, and then use the division theorem for limits. Yes? So it means that in principle, you really don't have any problems. Again, as before, I put my number there. If nothing strange happens, that is my number. Yes? And that's still valid. Okay, so, but then you have, by the way, you have to remember these numbers by heart. So sine of pi over 6 is 1 over 2 plus 2 times 1 over 2, and cosine of pi over 6 is the square root of 3 over 2. You simplify it yourself, okay? That's not a big problem. But the next one is a little bit more interesting. Okay, so what is the meaning? I want to take the limit of tangent of x. X approaches to pi over 2 from the left. From the left means a smaller than pi, or a little bit smaller than pi over 2. Because you know that some people think in this way. Because you know when you talk about trigonometry, you have this circle, and then pi over 2 is up there. Some people say that, okay, a little bit, I mean on the left side of pi over 2, the circle is on this side. But on this side is bigger than, so it means less than pi over 2. So can you tell me what is the answer to this?
It's going to go to infinity.
Somehow it should go to infinity because you have this limit sine x over, this is the yesterday's lesson. Yes? So do you remember what we learned before? So if I put pi over 2 here, sine pi over 2 is how much?
1.
Is 1. And cosine pi over 2 is 0. So you get a number top up there, and then you have 0. But of course, is this 0 exact 0 or infinitesimal? Infinitesimal, because I am not exactly standing on pi over 2. So it's an infinitesimal. Yeah. What type of infinitesimal? Positive infinitesimal or negative infinitesimal?
Positive.
Positive. Why? Because when you say x goes to pi over 2, less than pi over 2, it means you are still in the first quadrant. Yeah. And in the first quadrant, cosine is positive. So this is positive infinitesimal, and 1 is also positive. So the answer should be
infinity.
Plus infinity. Is that right? So what happens if this was plus? If x goes to pi over 2 from the right, everything remains the same, but pi over 2 from the right means above pi over 2. So I will be in the second quadrant. And the second quadrant cosine is negative. So it is negligible, but negative negligible. Then it becomes minus infinity. Is that right?
Yes.
Okay. But one of the most important, I don't know why the workshop, because in the book this is in chapter 3. No, in chapter 2. But I saw that there are a lot of workshop problems using this, so we have to go through it. Okay? So again, so I am destroying all mathematics, by this way of teaching. Because now I understand why they teach like this, because there is no time to have a good understanding of these things. So this is a very famous limit, so you have to send it to your memory, okay? Limit of sine theta over theta. Theta goes to 0. It is 1 if theta in radians. Extremely important. Not in degrees. Okay. Let me resist myself not to show you why this is true, because I know that we will not be able to finish everything. Okay, so take this for granted. But what type of limit is that? Is it indeterminate or not?
I think yes.
Yeah, it is. Because sine of theta, sine of 0 is 0, negligible. Infinitesimal, this is also infinite. So it is 0 over 0. So it should be indeterminate form. But none of the methods that we learned for lifting this indeterminacy will work here. You remember, we factorize things and we simplify things, but there is nothing here to factorize or get rid of it. I just want to give you the idea. The squeezing theorem and a little bit of trigonometry will allow you to understand that this is correct. Okay? But let us keep it and trust that this is correct. First of all, I want to, okay, let us keep it here. And I have written a remark for you. What do you think will happen the other way around? So if this theorem, take it for granted, what can you say about this limit now?
The same thing.
The same thing, why?
It's 1 over 1.
It's 1 over 1.
Yes, because in principle you can write it as 1 over sine theta over theta, and theta goes to 0, and then you can use the fraction rule, yes? The limit of the numerator exists, is 1, the limit of the denominator according to theorem exists and is 1, so 1 over 1 is again 1. So it doesn't matter if you write it in this way or the other way around, remember the limit is 1. Okay? Now, taking this for granted, let us pick some of these problems together and solve. Yeah, so let us start with the first one. Okay, so I want to calculate the limit of sine x cubed divided by x squared. X goes to 0. So one thing I want to mention here, I would recommend you to remember this theorem like this. I would say that sine of a box, okay, divided by the box itself, if the box goes to 0 is 1. Okay, so for example, if I ask you what is the limit of sine of x minus 2 divided by x minus 2, x goes to 2. Okay, so you see I am giving the role of the box to x minus 2, and this time I am saying that x goes to 2. If the box is x minus 2 and when x goes to 2, it implies that the box itself goes to 0. So this means that I am facing the same scenario. So the limit of sine x minus 2 divided by x minus 2 is simply 1 again. Is that understandable?
Yes.
Okay, but now let me just test your understanding. What happens if this goes to 0 now? Limit of sine x minus 2 divided by x minus 2, x goes to 0. Do I have a problem here?
Yes, it doesn't go to 0 anymore.
It doesn't go to 0, but can I solve it?
You can just put it.
Yeah, I can just put it. So remember, so first of all, whenever you want to calculate something, test what happens if I put 0 there. If I put 0 there, what happens? It becomes sine of minus 2 divided by minus 2. So do you remember this minus sign can be flipped out from sine, and that minus will cancel. So the answer just simply becomes sine 2 over 2. But this 2 is in radians, the 2 up there, okay? So is that understandable? Okay, now let us go back to the problem here. So what do you think I can do here? What can I do?
Multiply and divide by x to get the x cubed.
Yes, because I want to somehow use this theorem. This theorem is a sine of an angle divided by the angle itself. Okay? So I have to construct it. It is not hard. If you understand, then you can reverse engineer, you can engineer it yourself. So I would write it x, and because this is power 3, I put out power of 3. So far, it is not legal. Do you agree? Because I'm changing the problem, yes? This fraction to power 3 is the numerator to power 3, so far so good. But the denominator should also be raised to power 3. But the problem is that I have second power. So it means that if I write equality, it is illegal. Unless I compensate for that problem. So how can I compensate for that an extra x that appears here? Multiplied by x. Is that right?
Yes.
So this is the way you have to think. But now, is it solved?
No.
Yes, this problem, this one, is the same combination. And the good news is that x goes to 0. So do I know this limit?
Yeah.
Yes, so the limit is 1. The limit of x is 0. So the answer is simply 1 to power 3 times 0. So I am using these arithmetic theorems, and the answer will be 0. Is that right? Okay. What is the next one? So can you engineer it yourself now? So let me write it. Limit of sine x over 3x squared plus 2x, and x goes to 0. Can you engineer this? Somehow, first of all, again, you put 0, you see that you are in trouble. Sine 0, 0, here is 0, so it is indeterminate of the type 0 over 0. And because this sign appears here, it indicates that none of the techniques we learned before is apparently applicable here. So I have to use another method. So that's very important. This mindset you should have. Okay, but in order to use this theorem, I need a sine of an angle with the same angle in its denominator. Okay, so
we factorize x in the basis.
yeah, so for example, you can divide everything by x.
Yeah.
So that's the way. I just want you to learn how to think. If you learn how to think, it's not very hard. So this one I divide by x. What is the motivation of this action? Because I want to construct this.
Yeah.
Okay, it doesn't mean that because I want it works, but at least this is one strategy to tackle the problem. Yes. So if I divide this by x, then I divide this by x. What happens?
3x.
3x.
2.
Plus 2. Again, of course, is it legal? Yes, everything is correct. Okay, so is it working now, do you think?
Yeah.
Yes.
Yeah, because the limit of the numerator, according to the new theorem, is 1, and the limit of the denominator is simply 2. So the answer is 1 over 2. Yes? Okay, let us solve the next one. And then we can have a short break. Or you can have a break now, because I need to clean the board. But only 5 minutes, okay?